Welcome to all. Myself, Dr. Vishwanath, Department of E&C, Rajiv Institute of Technology, Hassan. In this video, I'm going to demonstrate how to design and test the RC phase shift oscillator using multisim. So first of all, let's understood what is oscillator. Oscillator is an electronic circuit that produces a periodic, oscillating or alternating waveform without the need for an external input signals. So without any external input signal producing the periodic signals, signal will be oscillating or alternating waveforms. And also it converts the direct current from a power source into an alternating current AC signals. And these oscillators used in many applications in the electronics device and systems for generating the signals in radio communication, audio synthesis, and clock generation, etc. So now this oscillator mainly classified into different types of oscillators. The harmonic oscillators. Okay, in this harmonic oscillator generated the sine waves with a low distortions and are used in applications like radio frequencies. And next type is relaxation oscillators. So these type of oscillators produce a waveforms like a square waves, sawtooth waves, and some others. And lastly, crystal oscillators. Now we discuss it. This is RC phase shift oscillators. So it is related to the harmonic oscillators. Our type of RC phase shift is related to the harmonic oscillators. The mainly the frequency. How much frequency generated this oscillators is depends upon that means the frequency of the oscillation is determined by the components within the circuits like the resistor, capacitor, and inductors. So based on this component we are using, the frequency is also determined. So in our experiment, I am taking the RC phase shift. The feedback we are using in resistor and capacitors to produce the signals. That is oscillated signals. Produce the oscillated signals. Now the phase shift. The phase shift oscillators. It is also electronic circuits that generate a continuous sinusoidal signal of a specific frequency. And these type of oscillators are mainly used use it in audio signal generation, frequency modulation, and tone generation. An RC phase shift oscillator produces a sinusoidal output signal by utilizing the phase shift principles. So the principle operated, that means the circuit consists of an amplifier with a feedback loop containing a network of resistor and capacitor. So here we can use an amplifier circuits, okay, using the op-amp or using BJT, whatever may be. That depends upon the components what we are using. So the circuit consists of mainly amplifier circuit with a feedback loop. That's very important. That produces the 180-degree phase shift, and that circuit consisting a network of resistor and capacitors. The phase shift network provides a 180-degree phase shift at the oscillator frequency, and the amplifier gain provides the remaining 180-degree phase shift required for the oscillator. The total phase shift of the signal is 360. So that means, once understood that, the phase shift amplifier circuit produce the 180-degree, and the component resistor feedback circuit produce the 180-degree phase shift. Now this is the our circuit, RC phase shift circuit diagram. So here the op-amp produce, that is amplifier produce the 180-degree phase shift minus K, okay, and the RC phase shift here I'm connecting the feedback connection base. So 3 resistors we are using and 3 capacitors we use it. So each loop produce the 60-degree phase shift of signal. So total sum of this 3 loop is 180-degree phase shift. So mainly in this circuit consists two main parts. One is third order cascaded RC filters and negative gain amplifier. So these cascaded RC filter produce the 180-degree phase shift, and negative gain amplifier produce the another 180-degree phase shift. Total is 360-degree phase shift. So the working principle of RC phase shift oscillators, I already explained that. That is, so it consists three third order cascaded RC filters and negative gain amplifier. The oscillation occurs at the frequency where the total phase shift through the three RC circuit is 180 degrees. So each feedback loop produce 60 degree. Now, so the amplifier is minus another 180 degree. So total the sum is 360 degree or 0 degree. So it satisfies the condition for oscillations. Okay, and for sustained oscillation, we need to satisfy this condition, that is greater than 1. And the attenuation B of the third order RC loop network of the RC phase shift oscillator is equal to B is equal to 1 over 29. And to meet this greater than 1 total loop gain condition, the closed loop gain of the amplifier K must be set slightly higher than the 29. So the frequency of oscillation is satisfied for an RC phase shift is 1 by 2 pi RC into root 6. Okay, so to calculate the frequency, oscillation at the frequency, okay, sustained oscillation at the frequency, so by using 1 by 2 pi RC root 6. So here R and C component values make an important role to produce the frequency. Now, so this is the practical circuits I'm using. Okay. Sorry. So this is the missing. Sorry. Oh, no, practical circuits. This is the practical circuits I'm using. RC phase shift. So op-amps using in these circuits, op-amp based RC phase shifts I constructed. Okay, so these C1, C2, C3 capacitors are used for the construction the feedback loop. Okay, each loop C1 combination with R1, so produce 60 degree. C2 R2 produce 60 degree. C3 R3 produce 60 degree. The output once again fed back to the input signal and the voltage, DC voltage I am applied to a non-inverting terminal. So now after constructing the completion of the circuit, okay, it's a very simple circuit. Use the 741 op-amp. So 12 volt DC voltage, 12 volt DC voltage. So go to place components. Here you can select the components, power source, okay, DC power, DC power. So now after selected, go to the once again mu A741. So directly if you want op-amp or select all families, op-amp mu 741, just you type here 741, not source here. Okay, 741. Okay, you got the symbol of our op-amp, just you select and place it. So, and capacitors C. So in this circuit we need the 3 capacitor and 4 resistors. All values you can okay. So feedback values are 5 kilo-ohm in design. Now once you just after the completion of the circuit connection, the next part is go to this run simulated this circuit. See, the sinusoidal signal is produced. Okay, so observe the oscilloscope. So waveforms are observed in oscilloscope. Just observed in the screen. So sinusoidal signals are continuously it is produces. Okay, so this is very simple. And also the same RC phase shift circuit can also the signal can also produce it by using BJT. So this is our another RC phase shift circuit using, instead of using op-amp, we're using the circuit. Okay, BJT circuit I am using here. So these are the feedback connections, C1, C2, C3, R1, R2, R3, and voltage divider circuits. Okay, voltage divider circuit. Is it? So okay, now just I run this is the circuit as also. So once you constructed the circuit, connected everything, after the completion of the component connection, the circuit built, then we go for simulated. So I hope you all of you understood that how to construct the RC phase shift oscillator in multi-sim environment. Okay, both using op-amp and BJT. Okay, so thank you for watching video.